Okay, so up to the four. Okay, fourth questions we had discussed in the last lab. Okay, so 1, 2, 3, that is a part of verification of planar or not. Okay, and then after question number 3, that is one of the theorem. Prove that first theorem means a K5, first graph which is a non-planar graph, and second graph is a K33 which is also non-planar graph. Okay, and then after in question number 4, that is also we had discussed, I think. Is it remaining? Question number 4. Okay, done. Okay, in that you have to first make this graph as a planar. Okay, and then after we can verify the Euler formula. What is the formula of Euler? That is n minus e plus f is equal to 2. Okay, n minus e plus f means f indicate the region, and we can assign the region only for planar graph. Okay, we cannot assign the region for non-planar graph. So here this given graph is look like a non-planar. Okay, so first make to the planar, clear, and then we can easily embed it, clear, and then after assign the region, clear, and then after find the vertex is given, 6 vertex edges, and then after check the faces, and then just verify the answer. That should be the 2, clear. So that is verification of Euler formula, clear, and any of the planar graph will always satisfy the Euler. If the graph is planar, then the formula will always work. Okay. So first draw this graph, clear, which is non-planar here, and then after apply the embedding, convert to the planar. Okay, and then after verify the Euler formula. Okay, and similar question is given in question number 5. There is some collection of graph is that some graph are planar and two 4 graph is given. Okay, first and second is a planar, but third and fourth is a non-planar. Okay, so verify the Euler formula of the following graph, clear. So in the first graph it's easy to verify the formula because it is a planar graph, clear. There is one vertex at the center, that is a G, clear, and we can easily assign the region as a 1, 2, 3, 4, 5, 6, and 1 is for outside, that is a 7, clear. And then after write Euler formula. So here Euler formula is equal to Euler's formula that we have n minus e plus f is equal to 2, clear. That is we have to verify, clear. So here number of vertex are 7, clear. 7 vertex are given. Number of edges 6 at the boundary and 6 at the inside. Okay, so 6 plus 6, 12 edges, clear, and faces are also 7. F is equal to 7, clear. So n minus e plus f, that is equal to 7 minus 14, 7 minus 12 plus 7, so that is equal to the 14 minus 12, and that is equal to the 2. Okay, so that is the verification. Okay, and then after write, that is verified. Okay, clear, that is your complete answer. If the graph is planar, then you can assign directly the faces, and then after we can check by using this. Okay, now try it for second graph, third graph, and fourth graph. Okay, second is also planar, so that's very easy. Third and fourth are non-planar, so apply embedding first and then check the answer. Okay, is there any confusion to anyone? Okay, so try it and then after we'll discuss next question. Yes, third graph is also planar. Third, now it is given non-planar condition is there, but we can easily embed. Okay, we can easily embed in it. So just remodified the graph, okay, as per the connection. Connection should be fixed. We cannot modify the degree. Clear? Degree should be same in your modified graph. Okay, consider 5 vertex as it is here, and then after create this given graph. Okay, again without crossover. Clear? Now B, C, A, F are intersect. Clear? So how we can remove this crossover? Just check it, and then after redraw the graph. Okay. It is planar. Okay. Fourth is also planar. Third is also planar. Okay. 6 vertex are there. Clear? Plus the F also. Yes. All of you are done it. Remaining. Okay. What about other student who are doing deep, Astha, Ekta, Jaivik? Is there any problem? Okay. Okay, all of you have done it. Is there any query to anyone? Any confusion in any of the graph? How we can convert to the planar? Maulik, Parth, Syam, Vishal. Okay. So in this, there is no any problem. Okay, in this 1, 2, and 4. 4 is also easy to make a planar. Okay, just एक ही edge आपको निकालनी है, and then after reconnect from the outside. In the third graph, you can do it by two way. Here, two planar graph you can create. One is you can keep this situation as it is here. Okay, all the vertex place are as it is. Clear? That is one possibility for to make this as a planar. Okay, boundary is also as it is here. That is 5 edges are considered as it is. This 3 edge also as it is. There is no any crossover between these 3 edges. Clear? And now problem are in between these 3 edges. Okay, between BC, AD, and AF. Clear? So what I will do, I just remove this AD edge from the outside. Clear? And I will recreate it from the inside. Okay, and then after keep AF as it is. Now you can see that there is no any inside crossover. Okay, and one edge is also remaining B and C, so that I can connect from the outside. Clear? Now all the edges are as it is. Clear? All the vertex are as it is, and this graph is now planar. Okay, and you can see that number of region are 1, there is a 2, 3, 4, 5. Okay, 6, and there is 7. Clear? 1 is the outside and 6 are the inside. Clear? That is one answer. And you can draw this graph by another way also. You just stretch this F, okay, to the outside. सिर्फ F को आपको outside पे draw करना है, ठीक है, उसको stretch करना है. So all the edges will be mapped as a outside. Clear? That is for outside 5 vertex. ठीक है? And that is edge BC. And that is AD. And now I stretch this vertex F to the outside. Okay? And then after make connection as per the view. Okay? F to D. That is our F. Okay? And one edge is also remaining. That is between A to F. Clear? Now you can see that it is also same vertex, same region. That is 3, 4, 5, 6, and this 7. Clear? So two answer is possible, means two graph is possible as a planar of the third one. Okay, you can consider any. So is it clear? Is there any confusion in question 5? Okay. Now question number 6, it is similar one. First check the graph. If it is a planar, then we can verify the Euler formula. If it is a non-planar, then we cannot apply the Euler formula. Okay. So first question is the Peterson graph. As we know that you can also draw the graph here. Clear? Peterson graph, that is by 10 vertex. Clear? Just draw the complete set here. Clear? And then after write a conclusion. Okay, here embedding is not possible in Peterson graph. Embedding is not possible in Peterson graph. Okay, because Peterson graph is non-planar and also embedding is not possible to make as a planar. Okay, in Peterson graph. So thus we cannot verify. Okay, we cannot verify Euler formula. Euler formula. Okay, that is answer of first one. First draw the complete graph of Peterson and then after write conclusion. Okay, here embedding is not possible in Peterson graph, okay, to make a plan. and therefore we can't verify Euler formula. Okay. And then after try question 2, that is the second option, that is a K34 and K23. So similar argument for K34 also, clear? Because we know that up to the K33 and all the graph after K33, that all are non-planar, clear? That is Kurotowaski's second graph we have as a minimum number of vertex, 6 vertex, clear, and 9 edges, which is non-planar. So it now involves the 7 vertex with 12 edges. So obviously it will be the non-planar graph. Okay. So similar argument, first draw the K34 graph, clear? 3 vertex in one side, 4 vertex in other side, draw it here, and then after uh, write the same conclusion. Okay. Here embedding is not possible in K34 graph. So here we cannot verify the Euler formula. Is it clear for K34 graph? Okay, now we can easily embed K23. Clear? So draw the K23 set. K23. Clear? That is actual shape of K23. K23. Clear? 2 vertex in one side, 3 vertex in other side. Clear? That is actual shape. And now here we apply the embedding process. So here embedding is possible. Same vertex, and now make all the connection without crossover. Okay. Two edges I create, one of from round side and one of the from above side. Okay. This is now planar. How many faces are there? One, two, and three. Clear? And then after verify the Euler formula. N is equal to 5. Edges are 6 and faces are 3. So 5 plus 3, 8. 8 minus 6 is equal to 2. So write the answer. Okay. And then after try it for K4. Okay. K4 is also planar. So consider planar form the K4. And for K6 write same conclusion. Embedding is not possible in K6. Okay. So therefore we cannot verify the Euler formula. If you have any query, any doubt, please ask. Otherwise do it. Yes, all of you have done it. Only two graph you have to verify. Okay, one is a K4 and second is a K23. Rest of all the graph are non-planar. Clear? So you just type the same answer. Embedding is not possible in K6, K34. So therefore, we cannot verify the Euler formula. Okay. So is there any confusion to anyone? Is all of you derived the answer? For K4, it is also possible the embedding. Okay. And in K4, you can easily verify Euler formula. What about the student? Only one student has replied. Deep, Maulik, Jyot, Risit, Siam. Have you done it? Okay. So that is question number 6. You can add some more graph here, which is planar. Okay. Otherwise, embedding is possible, and you can practice some more graph. Okay. And now in question number 7, that we already finished. Okay, during the lecture, you to write a proof here. G is a connected graph, connected planar simple graph with E edges, V vertex, and where V greater than equal to 3, and so that edge is less than or equal to 3V minus 6. Okay. This theorem we already proved in the during the lecture session. So you just revise it and then after complete in your book. Okay. I'll share this PPT again because we have to add two more questions which is given as exercise in this PPT. Okay. That we consider as a exercise of assignment. Okay. So just 1 minute. We just try it how we can prove it. It is a too simple result. We have to apply that. Okay. So you can also try it. Okay, there is a proof of this one. In place of V, here N is mentioned that. Clear? So read this proof carefully, clear, and then after complete in your book. If you have any doubt in any step, please ask. But read it, okay, understand each and every step, and then after complete in your book. In place of V, here E is N is mentioned, okay, but that is same. V is a simple connected planar graph with V vertex where V should be greater than or equal to 3. EA is F with the number of faces, then E less than or equal to 3V minus 6. Okay, that is in place of N, V vertex notation is there. So read it all the step carefully, understand it clear, verify each and every step for any of the graph clear, and then after complete the proof in your book. And this last statement is also very important. This is necessary condition, but not sufficient condition. Okay, it will verify it here in this next example, question number 8. Okay, here we will get one quadratic result. Okay, with number of 8. So in that case, we'll use this condition. It is only necessary but not a sufficient condition. Yes. Is there any query, any confusion in any of the step? All of you have finished it? Parth, Prati, Rishit, Vishal, Astha. Yes. Can you hear me? Am I audible? All of you have done it? All of you have finished this proof? Is there any remaining? Any confusion in any step? Meet, Mihir, Maulik. Yes, Maulik, can you hear me? Maulik, meet me here. Parth. Okay. Yes. So, no any confusion in this group. Okay. Good. So, next is question number 8. Okay, and we'll add two more question here, 9 and 10. That is practice given in this lecture note. Okay. That is last topic, graph coloring and uh, region coloring. Okay, that we discussed. And we can also add this question of dual graph. Okay, there is exercise given after that. I already solve it, but we'll solve it again. Question number 8. Verify E less than or equal to 3v minus 6 to the following graph and check this graph is a planar or not. Okay. So what this result indicate here? Clear? If we check this proof, clear? Which idea we can consider from this proof? Okay. If you need to create one of the connected planar graph, okay, which should be the simple also, connected simple planar graph, and how many edges is required? Okay, to create a graph by using n vertex. Clear? Create a graph by using n vertex. Clear? We need to create one of the simple connected planar graph. Okay, आपका ग्राफ planar भी होना चाहिए, connected भी होना चाहिए और simple भी होना चाहिए. ठीक है? Simple means no any loop as well as parallel edges. Clear? So how many minimum edges? Clear? How many edges is required to create this graph? ठीक है? To create the graph with n vertex. So here answer is E less than or equal to 3n minus 6. Clear? E less than or equal to 3n minus 6. For example, I need to create one of the planar graph, okay, by taking n is equal to uh, let us say 4 vertex. Okay. So how many edges will required? Okay. How many minimum edges is required to create that type of graph? Okay. So let's consider n is equal to 4. 4 vertex I have. So what will be the answer by using this formula? E less than or equal to 3 of 4 minus 6. Clear? So what is the answer you will get? E less than or equal to 6. Clear? E less than or equal to 6. And let's create this graph. Means up to the 6 edges you can use. Clear? To create a simple connected planar graph, up to the 6 edges you can use. Okay? So here Uh, let's connect this 4 vertex by one edge. So that is look like disconnected. Okay. Consider this edge also. Sorry. This one, and okay, I used the 4 edges. And now this graph is simple as well as connected. Okay. It is also planar. There is no any crossover between any two edges. But still I can use the two more edges. Clear? One is from inside. Still the graph is simple connected planar graph. Okay. I have used 5 edges. And last one, I can connect this to vertex also. Clear? So if I add one more edges now, okay, if I add one more edges, so it become a non-simple graph. Okay, if I consider one edges more between these two vertex, it consider as a not a simple graph. Okay, if I add a loop here, it is also contradict with the definition of simple. Clear? So therefore, how many edges I can use maximum? Up to the 6. Okay. So that you can define the boundary for that. Okay. We can consider up to the 6 edges. Just 1 minute. Clear? So here in this data, in these questions, we have uh, K5 is given that, okay, K4 is given that. Let me check for K4, okay. ये जो हमने solve किया है in this exercise, that is for 4 vertex, okay. And here it is, first consider the K4 shape, clear? And then after convert to the planar form, and then after check the edges, and that edges should be the uh, equal to this formula, okay, means up to the 6. And in K5 it will be not possible that. So similarly in K33 is also not possible, and K13 is also not possible, but in one of the case we will get one contradict result, clear? Okay, here in this K33, clear? How many edges in, let us take K5 example, how many edges are there? That is equal to 10 edges and 5 vertex. Clear? Vertex are 5 in K5, 10 edges are there. So if you apply this formula, E less than or equal to 3n minus 6. So E less than or equal to 3 of 5 minus 6. So E less than or equal to 15 minus 6. 15 minus 6. Okay, so that is equal to 9. Clear? And here we consider 10 edges, and up to the 9 edges you can consider the planar graph. Clear? But here we use the 10 edges, therefore it become a non-planar graph. Okay? And similarly in K33 you will get one contradict result here. Okay, as we know that K33 is non-planar, but if we check it by using this formula, so how many edges is required to create the planar graph? Vertex are 6, so 3 into 6 minus 9, 6, okay, minus 6. So E less than or equal to 12 minus 6, and E less than or equal to 6. Clear? So up to the 6 edges you can uh, consider to create as a planar graph by using 6 vertex. Clear? And here we use the 9 edges, so therefore it will be contradictory with it. Okay. So just try it by yourself. Clear? And if you have any query, any doubt, you can ask. I just save this location because there is one other lecture here. Okay. So stay in this meeting. Okay, we'll end this meeting after 10 minutes, clear? And then after you can uh, start the practice for mid exam. Okay, so all of you stay in this meeting. We'll take first attendance, and then after we'll conclude session. Okay? Okay, hello everyone. Am I audible? Okay. So, anyone have verified it? First one, K5. See, the question is here, check this graph's planar or not. Okay. So, if it is a planar, अगर वो planar graph है, then it will be verify the condition ages should be always less than or equal to 3v minus 6. Okay. Ages should be always less than or equal to 3v minus 6. If it is less than or equal to 3v minus 6, clear? Then it is called planar, clear? But here we get one contradict form. Let's see in which example we'll get contradict result. See in this K5, okay? K5, that is a non-planar graph as we know. Yeah. Okay, so as we know, it is non-planar graph, okay, where vertex are 5, edges are 10, clear? So let's verify by using this condition, clear? Okay, how many edges should be there? That is 3n minus 6, vertex are 5, so is equal to the 15 minus 6 means 9, means 9 edges should be there, okay? And here how many edges are given in this K5? There is 10 edges, therefore this K5 is a non-planar graph. Okay, here edges are 10, and by using this formula we get 9 answer. Okay? So therefore that is a contradict, and therefore that is K5 is a non-planar graph. Okay, and then after check for the K5, sorry K4. As we know that K4 is a planar, that is a planar graph. Here vertex are 4, edges are 6 edges in this K4. Okay, so let's check it by using this way. E less than or equal to 3n minus 6. edges कितनी होनी चाहिए? Up to the 3n minus 6 degree. ठीक है? So that is equal to 3 of 4 minus 6, and that answer is equal to 6. Clear? So here edges is less than or equal to 6, and how many edges are there in this K4? That is 6 edges. Okay. So therefore, we can say that K4 is planar graph. Okay. K4 is a planar. Okay. And then after check this concept for K33. So in K33, vertex are 6. Okay. And edges are 9. Clear? Edges are 9, vertex are 6. So as we know that it is a non-planar graph because we also verified. Clear? So how many edges should be there? Clear? There is up to 3n minus 6 to say it is a planar. Clear? So let's check the edges by using the formula. So edges less than or equal to 3n minus 6. That is, we have 3 of 6 minus 6. Okay. And that is 6, 18 minus 6. Okay. And 18 minus 6 is equal to 12. So here we get 12 answer. And how many edges are there in this K33? That is 9 edges. Okay. So that we get uh, conditions means contradict form. Clear? If it is a planar form, then how many edges should be there? It is up to the 12. Okay, if it is up to the 12 edges, then we can easily create a planar graph by using the 6 vertex. Okay, if we have up to the 12 edges, then we can easily create planar graph by using 6 vertex. But now it is a K33 graph, and as we already verified that in this Kurotowa's second graph, it is a non-planar. And how many edges are there? There is 9 edges, and it is less than 12 also. Okay, 9 is also less than 12, but yet it is a non-planar there. Okay, so there we get one contradict form here. Okay, this condition is a necessary condition, but not a sufficient. Okay, it is only necessary condition, but it is not a sufficient condition. For all such graph, we cannot use this formula. Okay, to create for all such graph, we cannot use this formula. Clear? That is not verified in all the graph. Okay, so here we get answer is equal to the 12. Clear? And how many edges are there in this actual graph? There is a 9 edges. So 9 less than or equal to 12, that is a correct one. But here the graph should be the planar, but here we verified that it is a non-planar graph. Okay. So here it is a contradict with our statement, with our result. If it is up to the 3n minus 6 edges, then it should be the planar. Okay. But for a K33 graph, it is a non-planar. So that is a contradict with our statement, and therefore we can say that it is a necessary condition. Sorry, condition, but not a sufficient. Okay, so in this graph we get contradict. Clear? In K33. And now you can easily check for K13 graph. Okay, the last one. It is bivertite K1, 3. Okay, 1, 3. So how many vertex are there? 4 vertex. And as you know that K13 is a planar. Okay, it is a planar graph when we draw it. And how many edges are there? There are 3 edges product. Okay, so let's check by using the formula how many edges should be there. 3 and minus 6. So that is equal to 3 of 4 minus 6. Okay, and 3 of 4 minus 6 means is equal to 6. Clear? Means up to the 6 edges it's valid. Okay, to create a planar graph. And how many edges are there? Here it is a 3 edges. So here K13 is a planar graph. And here edges are 3 in the K13 graph. Okay. So thus it is a planar graph. Okay. Therefore it is a planar graph. So this is solution of this question number 8. Okay. So here we'll keep up to this. In the next lab, we'll discuss 2 more questions related to the dual graph and the graph coloring. Okay, we'll add 2 more questions in this assignment also. Clear? Is there any confusion in this answer? Here in this K33 graph that you get contradict form. यहाँ पे ages 9 है, and by using the formula it should be up to the 12. Okay, you can consider up to the 12 ages to say it is a planar graph. And here 9 ages are there, and also it is a non-planar. So therefore we get contradict form, and in that case we can say it is a necessary condition but not a sufficient. Remaining all the cases it will be verified. Okay, in this K5 you can verify that why it is a नॉन प्लानर, क्योंकि 9 एजिस होनी चाहिए फॉर द 5 वर्टेक्स के लिए, और यहाँ पे कितनी है 10 एजिस है. सो इन दैट केस इट इज नॉन प्लानर. In this K4, how many edges should be there? 6 edges should be there. Okay, and how many edges are in the K4? 6 edges are there. So therefore it is planar. Okay, and in K13, how many edges should be there? In K13, how many edges are there? 3 edges. Yeah, it is a planar. And as per the formula, how many edges you can consider? 6 edges you can consider to create a plan. Okay, and we have in this boundary that is a 3. So that is also a planar graph. Yeah, any confusion to anyone? Okay, so finish up to this question, and in the next lab we'll add 2 more questions, and then after you can submit this assignment in the Google Classroom. Okay. Those who have not submit assignment 5, I will put 0 mark for that assignment. Okay. Till some student, 2 to 3 student have submitted today. Okay, the assignment 5. So I consider 0 mark for that assignment because last date was the Saturday. Okay, before this holiday. Submit your assignment as per the given time limit. Okay, otherwise you will get 0 mark for that assignment. Okay, so now start the practice for your mid